Hello dear students, another lesson, Giancoli physics for scientists and engineers. Okay, so now in this lesson I am going to discuss very important topic, that is electrical power. So electrical power, this is topic about the household things. For example, different devices use has different capacity of different powers. So for example, bulb has 20 watt, iron has 1000 watt. So what is these watt? These watts are basically the power of that, the energy they consume, electric energy they consume. Okay, so let me describe, so let me define the power. So electrical power is basically energy transferred per unit time, energy transferred per unit time is called electrical power. So electrical power P is equal to energy transferred per unit time T, or in other words we can also say the work done per unit time. So these are formulas for power. So that in household things, for example, bulb use 20 watt. These watts are basically the energy they consume. Okay, just like iron consume 1000 kilowatt or 1000 watt. So these watts mean that how much energy they consume. Okay, so that the power is defined as energy per unit time. Okay, so how the energy is consumed, basically in order to understand this, electric energy is useful because it can be easily transferred onto other form of energy. So electric energy is useful because it can be transferred from one form to other form. Just like, for example, electric energy in the motors, electrical energy is converted into mechanical energy. Mean the motor runs, its motor runs. When motor runs, it perform mechanical work done, or its energy converted into mechanical energy. And similarly in other devices such as electric heaters, in the electric heaters, so electrical energy is converted into heat energy or thermal energy or heat energy. Okay, and similarly stoves, toaster, hair dryer, these also use some useful energy. These also converts electric energy into useful form of energy. Okay, and you can say that the electric energy is transferred into thermal energy in a wire. The resistance is known as heating element. Okay, because in the heater we have a heating element that heat up and then it gives us a thermal energy. Okay, so in the light bulb, electrical energy is converted into light energy. So light energy is the useful energy. So in most cases the devices use electrical energy to convert the useful energy. Light bulb, the tiny wire filament, basically in the light bulb has a tiny filament. Filament is a metal. Light bulb has a filament inside, just like that. Light bulb has a filament, this like filament, this is the metal. Okay, so when this is a metal, when the current flows through this filament, so that it converts into light, it gives us the light. So it converts into light energy into electrical energy. Okay, but not only all the energy is transferred. If light bulb gets 100% energy, but some energy is converted into visible light, but rest of the energy is converted into heat energy. If we touch, for example, if we touch any bulb, we see that the bulb is warm. So it means that not only it gives us the light, it also converts some energy into heat energy. So this heat energy is taken as the loss in the light bulb, because heat energy is not useful in the case of light bulb. Light bulb filament heating element in the household application has resistance typically. So its resistance is mentioned few ohm to the few hundred ohms. Electric energy is transferred into thermal energy or light. Such devices, there are many collision between. So how the energy is converted? So it is basically in these devices there is a metals, and these metals, when charges move through, flows through these metals, for example in any device, so it has the atoms inside it. So when the current flows through that, when the current flows through that, mean current flows through that, mean the charges move through that. When the charges move through that, these charges collide with the atoms, and when these charges collide with the atoms, so that the atoms kinetic energy increases. So these atoms moves at a faster rate, their kinetic energy increases, because when kinetic energy increases, so the temperature T of these atoms increases, so that these temperature increases, so this heat energy is accompanied by other forms of energy. Some way it gives us heat, some way it gives us light, some way. So these thermal energy is converted into other forms of energy. Okay, there are many collisions between the moving electron and the atom of the wire. In each collision, the part of energy, electron's energy is transferred to the atoms, which makes collide. As a result, the kinetic energy of the wire atom increases, hence the temperature of the wire element increases. And the increase in thermal energy can be transferred as a heat by conduction. And so what are the conduction, convection and radiations? So these energies transferred by the either conduction, convection or the radiation. So conduction is the process in the heaters. So there are three processes by which the energies, heat energy is transferred from one place to another place. So what is the conduction? Conduction is the process in which the heat is transferred by the actual movement of molecules or atoms. For example, just like in the heater, conduction phenomena is in the heater, because the heating element, it will transfer energy from one place to other place, so by the actual movement of the molecules. For example, the rod of the heater, for example, this is the rod of heater, so that the atoms collide and the atom pass heat from one place to other place by the actual movement of their vibrations. This is the process of conduction. When the heat in the heater, the atoms collide and they will pass the heat to the other portions. But in the convection, the heat is transferred by conduction is in the solids, mostly happen in the solids. But in the convection, this process convection is happen in the gases or gas or the liquid. For example, we have in the room we have a radiator. And these radiator, the air particles, it heat of air particles, because radiator transfer is heat to the air particles, and these particles flow and they move to, and they rise, and they also transfer this heat to other parts. Okay, so this actual movement of molecule, because particles move from one place to other place. So this is the liquid and gas particle. This is process is convection. By the actual movement of molecules, the heat transfer heat from one place to other place. And the number third is the radiation. The heat is transferred through the radiation. Radiation is the phenomenon in which the heat is transferred by the electromagnetic rays, electromagnetic radiations. Just like in the oven we have microwaves, and these waves try to heat up the food. So these are the radiations. So that heat transferred by the radiations, electromagnetic radiations. These electromagnetic radiation heats the environment or something. Okay, so there are three processes in which the heat is transferred from one place to other place. Okay, now we discuss the power. Now we derive the power formula. So the power is basically can be derived that you know that the energy is power P is equal to, let me discuss this one. So power formula, derivation of the formulas for power. So that as we know, the energy is equal to charge multiplied by change in potential. So the energy transferred del U equal to charge Q multiplied by potential V. This is formula for energy. Del U is the energy, Q is the charge, V is the potential. So the power is defined as energy per unit time. So du can be replaced by the dq into V over dt. So this dq over dt is basically current I. So the P is equal to I into V. So this is another formula for power. P is equal to IV or VI. Then if we put V is equal to IR according to Ohm's law, though this will give us I square R. So this is another formula. P is equal to I square R. but if we put instead of V